to another A-Level Computer Science video with me, Mr Goff, for MrGoff.com. This video will focus on the components of the processor. At GCSE, we learned that a processor has an arithmetic logic unit for performing calculations and making logical comparisons, a control unit that coordinates the activities of the CPU and directs the flow of data between devices, and a system clock that helps synchronize the actions of the processor. The section you see here marked registers within the arithmetic logic unit are known as general purpose registers. These registers are very fast, small storage areas on board the processor. General purpose registers are also known as accumulators. They can be used to hold interim values during calculations. For instance, you might get an instruction that asks for the contents of memory location 21 to be subtracted from the contents of memory location 13, and for the answer of that to be stored. This might translate to load the contents of location 13 into register 1, subtract the contents of location 21 from what's in register 1, store the contents of register 1 into location 22. There are also a number of dedicated registers in a processor that are used to run the processor, such as the program counter, labelled PC. This holds the address of the location in memory of the next instruction. The current instruction register, or CIR for short. This holds the current instruction being executed. The memory address register, or MAR for short. This holds the address in memory to read or write instructions or data to or from. The memory buffer register, or MBR, is sometimes called the memory data register, or MDR, because it temporarily stores data and instructions. The status register, or SR, is used to indicate an overflow or a negative number or a number of other signals. Let's have a look at how the fetch, decode, execute cycle works with our more complex view of a processor. We start with the program counter, which holds the address of the next instruction. This address is copied to the memory address register and sent to main memory on the address bus. A control signal is sent to main memory to request it to return the contents stored at the memory address. The instruction stored at the specified location in main memory is sent to the memory buffer register on the data bus. At the same time, the program counter is incremented so that it shows the address of the next instruction to be fetched. The instruction is then copied from the memory buffer register to the current instruction register. Next comes the decode stage. The instruction in the current instruction register is decoded into its opcode and operand, and the opcode is looked up to see what instruction needs to be carried out. If additional data is needed at this point to carry this operation out, it will be fetched from main memory and passed to the registers. Finally, the instruction is executed using the ALU if necessary. The result of any calculation is stored in an accumulator or sent via the memory buffer register on the data bus back to main memory. If a calculation resulted in an overflow, a signal would be sent to the status register, or if we were in another circumstance, there are other reasons we might send a signal to the status register. That brings us to the end of this video on the components of the processor. Join me in the next video when I'll be looking at the processor instruction set. Use the resources at MrGoff.com to help you revise computer science. And until next time, it's bye for now.